Good morning, Course 2. Here we are for Lesson 105. This is one of our more difficult lessons to learn, though it is based on things that we already know and understand, so it shouldn't be super hard. We are going to be talking about the surface area of a right solid and the surface area of a sphere. The only really new information is going to be the surface area of sphere, and we figure out that by using a special formula that we haven't used before, and that is, I know I saw it somewhere, 4 pi r squared. That's our new formula for today. Everything else will be stuff we have done before. So looking on we're starting on page 731. And this is going to be about the surface area of a right solid. Recall that the total area of a surface of a geometric solid is called the surface area of the solid. Look at the block over on the side. It has labeled top, front, and side. And each one of those three places have a matching piece. So the top matches exactly what's on the bottom. And the front matches exactly a piece on the back. And the side matches exactly the side piece. So when we figure these things out, there's actually 2 for every side. So they want us to figure out how to calculate a surface area. So let me see if I can first draw this picture. Semi-close. Ooh, bad. Oh well, I can't say it's because I'm on the board. Here's the top. Here's the front. Here's the side. They give us 3 centimeters, 5 centimeters, 6 centimeters. All right. So let's look for a second. Let's say I'm going to do the front first. Here's my front. One side of it, I'm looking for the surface area, so I'm looking for area. So this is, I'm going to put down front. And it's 6 centimeters times, well, I need this that's going up, so it's going to be this 3 centimeters. All right? So now I have 3 times 6, 6 times 3 is 18 centimeters squared. But I have a front and I have a back that matches, so I'm going to take this answer and multiply it times 2. So now I have 36 centimeters squared. Now I'm going to the side. I have the length, which is 5. I'm going to put side here. I've got 5 centimeters times the height, which is 3 centimeters. So 5 times 3 is 15 centimeters squared. And because I have a side here and a side here that matches perfectly, I'm going to multiply it times 2, and that's going to give me 30 centimeters squared. Now I'm going to look at the top. Okay, the top is 6 centimeters by 5. It matches this one, right? So by 5 centimeters, that's going to give me 30 centimeters squared. But I have a top and I have a bottom that matches it, so I'm going to multiply it times 2, and that is going to give me 60 centimeters squared. Now to find out the surface area of all of them, I'm going to add them up. So 6 plus 0 is 6. 3 plus 3 is 6, plus 6 is 12. So I have 126 centimeters squared for my lateral surface of the whole box. All right, not so tough, huh? Now we're going to get into example 1. And I will again try to draw this. This is a triangular prism. So there are two sides that are triangles. Let me see, how do I do this? So first we probably need to figure out, this is 90 degrees, 4, 3, 6, and 5. There are my, and everything's in centimeters. There are my dimensions. I have a triangle here that matches a triangle over on the other side. But that's the only thing I have matching in this particular drawing. I do have a top that we see here, but there's not a matching top on the other side. I have a rectangle. Let's see if I try to put this in a little bit. Oh, that's not too bad. So there are two triangles. There is a top that's also a rectangle. There's a rectangle for the back. And there is a rectangle for the bottom. So instead of having 6 sides like my prism, I have 1, 2, 3, 4, 5 sides. So that's what I'm going to end up trying to figure out. So let's start with the two triangles. They match each other. So in order to get the area of a triangle, area is base times height divided by 2. All right, so our base is 3. 3 times our height is 4 centimeters. There should be centimeters there. Divided by 2. So our 12 centimeters squared divided by 2 is going to give us 6 centimeters squared. That's for one triangle. But it has a matching triangle. So we're going to multiply this one by 2. And we're going to end up with 12 centimeters squared. That's going to be the two triangular sides. Now let's look at the top, because that one's easy to see. This side is 5 centimeters. This side is 6 centimeters. So now I have the top, what I labeled the top is 5 centimeters times 6 centimeters, because it's a rectangle, which is going to give me 30 centimeters squared. Okay, now the bottom that this sits on, well, let's see. This side of the rectangle would be 3. I'm going to call this the bottom. 3 centimeters. And the side length is going to be 6 times 6 centimeters. And there's only one of those. No other shape is the same. So it's going to be 18 centimeters squared. So here's the top. Here's the two triangles. Here's the bottom. And now I'm going to do the back of it. So this is, I'm labeling the back. The back going across is the same here. So it's 6 centimeters times, okay, the dimension of the back is going to be this dimension right here, matching the triangle. So that's going to be 4 centimeters. 6 times 4 is 24 centimeters squared. And there I have my 1, 2, 3, 4, 5. So I'm going to add these up, 12, 30, 18, and 24. 10, 14, 1, 2, 3, 4, 5, 6, 7, 8. 84 centimeters squared. 84 centimeters squared. And that is my answer to get all of those put together. Okay. Now, the total lateral faces on that particular, let me put this back. The triangles are not included in the lateral faces. The lateral faces are the ones that just go around that are rectangles. There's a quick way to figure it out to find the prism without the end pieces. is to multiply the perimeter of the base by the height, the distance between the bases. The perimeter of the base times the height. Okay, so if we looked at the perimeter, it would be 5 plus 3 plus 4. 5 plus 3 plus 4. Which is going to equal 12 centimeters. And then you're going to multiply it times the height, which is if we took this and set it this direction, so we set it on its triangular end. So the height would be 6 centimeters. 6 times 2 is 12. 72 centimeters. Okay, so now we've got 72 centimeters, which is the lateral side. And we're going to add the triangular sides, which this is centimeters squared. We're going to add the triangular side, which is 12 centimeters squared. I've got that from here. You add those together, and you have 84 centimeters squared, which is just like this. So if you can learn to do the lateral sides without making a mistake, that's another way that you can actually figure that out. Okay, let's look at example 2. And we are going to be finding out the area of the label on a soup can. So let me draw my soup can. Here's my soup can. It's got rings there. From the edge to edge, so that's the diameter. The diameter is 7 centimeters. And from the top down to the bottom, that is 10 centimeters. And they want us to use 22/7 for pi. Okay, what is the area of the label on the can with the dimensions shown? All right, what we have to do here, and because they stick and they won't turn out good, I won't do it myself. We're going to remove the label. So if I take my scissors and I chop it right here, what I'm going to get is a flat label that looks something like this. Whoa, that's because it tore while I was pulling it out. Okay, so I have my soup can. This is the height. This is the circumference. Now, why is it the circumference? Because that label came from the round can. So around the surface of the can would be the circumference of the soup label. Here's my soup label. Okay, so to figure this out, they want us to figure out in A, they want us to figure out the area of the label. They want area. Okay, we know area is length times width. So in this case, it would be circumference times height of the can. And that's the information we have to get. We know the height easy. The height is 10 centimeters. But we're going to have to figure out the circumference. And they gave us the diameter, so that should be no problem. So circumference equals pi times diameter. And here they want us to use 22/7 times 7 centimeters. Well, that actually works out really convenient for us, doesn't it? So now we have 7s are going to cancel, and we end up with 22 centimeters. So that's what's going to come over here for the circumference. 22 centimeters times 10 centimeters. We multiply 22 times 10, and we're going to get 220 centimeters squared. That's the area of the label, 220 centimeters squared. Okay, then they want to know what the total surface area of the soup can is. Well, we got the area of the label, which covers the lateral side of the can. Now we need to find out what is the area of this circular part. If we have one here, we also have one on the bottom. Otherwise, our soup would fall out before we got home, right? So we have two circles that we have to figure out. So we have the area of the circles is pi r squared. So for our cans, we have 22/7 times, well, r squared.